Hi there everybody, welcome to my YouTube channel. So today we are going to solve some important questions from chemical periodicity, or you can say periodic properties. That is the first chapter of your chemistry syllabus of class 10. So today's first question I will tell you, but before that I want to say you that in my earlier video I have explained all the things relating to this video. Like I have explained you what is electron affinity, what is ionization potential, what is electronegativity, metallic character, non-metallic character, atomic size, their dependency, everything I have told you. So if you don't watch out my earlier video, please watch it out first and then come to it so that you can understand the whole part of the video or the solution that I am going to tell you. Okay, so I have also suggested you to memorize some of some of the elements of chemical periodic table. So I have told you to remember elements from 1 to 20 and also some groups, some common groups. For example, the group 1, group 2, or the group 16, 17, some groups I have also told you to remember, and also I hope that you have done my previous exercise, and if you don't, first memorize them and then come back to the lesson. Okay, so today's first question is, a group of elements in the periodic table are given below. Boron is the first member of the group and thallium is the last. So if you have watched out my earlier video, will definitely say that I am going to say about group 13 elements, that is the boron family. So the first question is, which element has the most metallic character? Okay, so this is boron, this is aluminium, this is gallium, this is indium, and this is thallium. Okay, so the first question is, which element has the most metallic character? Okay, remember I have told you that as going down the group, as the atomic size of the elements is increasing, definitely the effective nuclear charge of the nucleus to the outermost shell electrons will decrease. As the effective nuclear charge of their nucleus to the outermost electron is decreasing, definitely their tendency to lose one electron from the outermost shell is increasing. And we know that metallic character is the tendency of those elements to lose electron from its outermost shell. So definitely as we go down a group from boron to aluminium to gallium, then indium to thallium, as the atomic size is gradually increasing, their metallic character is also increasing because the tendency to lose one electron from their outermost shell is increasing. That is why their metallic character is increasing, and from this we can conclude that thallium Tl has the most metallic character. Next, move on to the next question number B. Which element would be expected to have the highest electronegativity? Okay, for electronegativity I have told you that electronegativity is the tendency of an atom or the nucleus of an atom to attract the outermost shell electron pairs towards itself. That if one element has most electronegativity, it means that it has the most power to attract the outermost shell electron towards its nucleus. So as we know that from boron to aluminium, gallium, indium, thallium, as the atomic size is increasing, definitely the effective nuclear charge is also decreasing, and thus their tendency to attract the outermost shell electron pair towards itself is gradually decreasing. So if we say that boron that has the least atomic number and hence the least atomic size, it will attract its outermost electron pair more closely. That is how we can conclude that boron of this boron family has the highest electronegativity. Okay, so next is, If the electronic configuration of aluminium is 283, how many electrons are there in the outer shell of thallium? Okay, we have also discussed this part in my earlier video, that along a group, each element has the same number of electrons to its outermost shell. That means if aluminium has 3 electrons to its outermost shell, as thallium is also the same, so the member of the same group, it means that it also has 3 electrons in its outermost shell. Okay, the next question is, atomic number of boron is 5. Write the chemical formula of the compound formed when boron reacts with chlorine. Okay, so boron is 5, it means 2, 3 Kl. So it has 3 electrons to its outermost shell, that is the Al shell. So when chlorine react to it, as we know that chlorine has non-metallic character, so definitely it has a tendency to react with any element in a covalent bond. We have also discussed about covalent bond in my earlier video. Please watch it out. So as boron has 3 electrons to its outermost shell, so it will share 3 electrons with 3 chlorine atoms together and thus make BCl3. So write the chemical formula of the compound formed when boron reacts with chlorine. So it will be BCl3. So next question is, will the elements in the group to the right of this boron group will be more metallic or less metallic in character? If you watch my earlier video, I there explained everything, why the metals, why the left side elements of periodic table is more metallic than the right side element. I have explained there everything, so please go and watch the video. So definitely if you watch it, you can answer the question. The answer is that the elements in the group to the right of this boron group will be less metallic in character. And why? I have discussed these in my earlier video. Please watch it out and answer me in the comment section. Now move on to the next question. The next question is, arrange the following as per instructions given in the brackets. So the first question is magnesium, chlorine, sodium, sulfur, silicon. Decreasing order of atomic size. So one thing you must remember always, that whenever you are told to arrange something in a decreasing order, then you have to start with the greatest or largest and end up with the smallest or least. So here atomic size, I have told you that if you look at the elements carefully, that they all are of same period. Sodium having atomic number 11, magnesium having atomic number 12, sulfur having atomic number 16, silicon having atomic number 14, and chlorine having atomic number 17. So as we move left to right along a period, we will see that the atomic size will decrease as the effective nuclear charge is increasing along a period from left to right. So your answer will be sodium having the greatest atomic size, then magnesium, then silicon, then sulfur, and then chlorine. Now the question is decreasing order of atomic size. So you have to start with the greatest or largest element, this is sodium, and end with the least or smallest element, that is chlorine. I hope it is clear to you that the next question is increasing metallic character. I hope you all watch out my previous video where I have told everything about metallic character. Metallic character is the tendency, or you can say that it is the tendency of metals to lose the electrons from its outermost shell. So if element has the highest tendency of losing electrons from its outermost shell, we will say that it has a very high metallic character. So I have also told you that along a group, if we move from top to bottom, we'll find that the metallic character is gradually increasing, because as the atomic size is increasing, the metallic character, or the tendency to lose one electron from the outermost shell, is increasing, and thus the metallic character is increasing. So here the order will be cesium, because it is the bottommost element of group 1, and then come rubidium, potassium, sodium, and lithium. Okay, so this is all the elements are from group 1, and this is the decreasing order of metallic character. So, but here the question is increasing metallic character, and increasing is exactly the opposite of decreasing order. It means that there you have to start with the least or smallest element and gradually move on to the highest or greatest element. Okay, so here the smallest element is lithium, then sodium, then potassium, then rubidium, and finally cesium. So this is the correct order or the correct answer of this question. So next move on to question number C: sodium, potassium, chlorine, sulfur, and silicon. So if you watch the elements, then you find that sodium and potassium are the elements of same group, while sodium, chlorine, sulfur, silicon are the elements of same period. And the question is increasing order of ionization potential. Ionization potential is the energy required to remove an electron of a gaseous atom to make it a gaseous cation. So the energy required is important. So if any atom just loosely bounds its outermost electron, it will require less energy to remove the electron from its outermost shell. So along a group, as the atomic size is increasing from top to bottom, so definitely the ionization potential will reduce, while along a period, as atomic size is decreasing, as the effective nuclear charge is increasing along a period, so we can conclude that the correct order will be potassium, then sodium, then silicon, then sulfur, and finally chlorine. These elements are same in the period, while these two elements are of same group 1. I hope you understand, and I also have arranged them in the correct order. Here the increasing order of ionization potential. So what is increasing order and decreasing order? I have just told you. So next move on to the question number D. It says that chlorine, fluorine, bromine, iodine arrange themselves in an increasing order of electron affinity. So what is electron affinity? Electron affinity, I have told you that it is the energy released when you are converting a gaseous atom to a gaseous anion, and the energy release. So if you have greater effective nuclear charge and you just tightly hold your outermost electron, then definitely you will release more energy, or you will get more stability. If you are given electron to your outermost shell. Similarly, why I have told that energy is related to stability, because that if an atom can only gain stability if it loses energy. So when for example chlorine, if it has 2, 8, 7 electronic configuration, so if it just get one electron to its outermost shell, it will get an electronic configuration like what? Like an inert gas, and that is argon. So thus it will get a stability. So as it is getting getting stability, thus it will release more energy. So that is the question. So here chlorine, fluorine, bromine, iodine, if we watch them carefully, we will find that they are from halogen family and they are along a group. The same element, that they are the elements of common groups, that is group 17. So I have told you, if the atomic size increases along a group from top to bottom, the effective nuclear charge will decrease, and thus the atom will hold its outermost electron loosely, and thus the electron affinity of this atom will gradually decrease. So here the answer will be iodine, bromine, chlorine, fluorine. We can say that. But you where here this iodine has the least electron affinity because it has greater atomic size, and thus its electron affinity will definitely reduced. Okay, but one thing you must remember, these two elements. So fluorine having greater nuclear charge, greater effective nuclear charge than chlorine, bromine and iodine. So definitely fluorine will have a smaller size than the other atoms. So due to its small size, it cannot release high energy, because if it gets one electron to its outermost shell, yeah, it will definitely get a electronic configuration like neon. But what happens to it, that there will be an electronic repulsion in its outermost shell, as the size of fluorine is relatively smaller than chlorine. That is why it will have it will release less energy than chlorine. So the final answer will be iodine, bromine, fluorine and chlorine. So chlorine will have greater electron affinity as it will be the most stable if it get one electron to its outermost shell, and thus it will release more energy as it is gaining more stability. Okay, I hope you understand the relation between stability and energy. Okay, let's move on to the next question. The next question is cesium, sodium, lithium, potassium, rubidium with decreasing electronegativity. So if you observe them correctly, then you will find that they are the elements of same group, that is the group 1. So I have previously told you that if the atomic size increase and then effective nuclear charge will decrease, that in that case as the effective nuclear charge will decrease with increasing atomic size, the tendency to hold the outermost shell electrons of atom will gradually decrease as the atomic size is increasing and effective nuclear charge is decreasing. So along a group, if we move from top to bottom, we'll see that the atomic size is increasing, thus the effective nuclear charge is reducing, and finally for this reason the electronegativity is also decreasing. Electronegativity, I have told you what is electronegativity, and if you watch out my earlier video, definitely you will understand what is electronegativity. So the final answer will be like that. Okay, here lithium will have greater electronegativity because of its less atomic size than the other elements of the group. I hope you all know their atomic number. If don't know, please keep periodic table in front of you and then watch the video. Okay, so my next question is potassium, lead, calcium, zinc increasing reactivity. So reactivity is something that depends on the metallic character. Metallic character means, so if there is the tendency of losing an electron from the outermost shell of an atom is increases, then its metallic character is also increased, and as the metallic character is increasing, its chemical reactivity is also increasing. So if you observe the periodic table carefully, we will find that sodium, calcium and zinc are the elements of same periods. Lead is somewhere in having atomic number 82, potassium having atomic number 19, calcium 20 and zinc 30. So they are from the same periods, and I have told you that along a period from left to right, we'll find that the metallic character is gradually what? Gradually it is decreasing. So as metallic character is decreasing, their chemical reactivity is also decreasing. So the final answer will be then calcium, then zinc and then lead. So next move on to the next question. The final question is G. Lithium, potassium, sodium, hydrogen, decreasing order of their potential ionization. So actually potential ionization is nothing but the ionization potential. So ionization potential, what is it? I have told you just shortly. What is ionization potential? It is the energy released. Is it? No. It is the energy required to remove an electron from the outermost shell of a gaseous atom and to convert it to a gaseous cation. Okay, so along a groove, if we move down from top to bottom, we'll find that as the atomic size is increasing, the effective nuclear charge is decreasing, and thus the electrons of outermost shells is loosely held. That is why we can conclude the answer will be hydrogen having the what? Having the lowest ionization potential, as it has the least tendency to lose one electron from its outermost shell, as the size of hydrogen is very less compared to the other elements of this group. So it starts with hydrogen, then come your lithium, and then sodium, and then finally potassium. Atomic number of hydrogen is 1, then lithium is what? Lithium is 3, sodium is 11, and finally potassium is 19. So it is said that you have to arrange them in a decreasing order. So the decreasing order where it starts with the greatest or largest element. So here the largest, the elements having the greatest ionization potential is potassium, and then sodium, and then lithium, and then hydrogen. So here the ionization potential is gradually decreasing from gradually increasing from potassium to hydrogen. So the ionization potential is rising in this way. This is the final answer of all the questions A, B, C, D, E, F, G. So I hope guys you understand whatever I am going to say over here. I will again tell you that please watch the earlier video that I have already made, where I have explained all the things, electronic affinity to electronegativity, metallic bond, covalent bond, everything. And you know what, that is the most important. When we will learn about the chemical bond, then metallic bond and covalent bond is also very important. So I have given a short note there. I hope you understand. So and enjoy the session. So if you have any doubts, any queries, do straight to the comment section. Comment, ask, and if you have any particular doubts or you feel that this question or that question is quite tough for you, then mail me. I will make a separate video for all those questions that was looking quite tough for you, and just all. So I hope guys you enjoyed it. Okay, for now, goodbye.